Okay, so welcome back to my video. This is chemistry form 4 chapter 5. Okay, today we will cover another subtopic. Okay, we will learn about types of bond other than ionic bond and covalent bond. So 5.4 here, hydrogen bond. Okay, so you should be able to explain the examples of the formations of hydrogen bond and the effect of the hydrogen bond on the physical properties of substance. Okay, this is for 5.4 hydrogen bond. So what is hydrogen bond? Hydrogen bonds are attraction forces between hydrogen atom H that has bonded with another atom of high electronegativity. So another atom of high electronegativity, the examples are such as nitrogen, oxygen, fluorine. Okay, semua ini adalah contoh-contoh atom yang high electronegativity. So what is electronegativity? Electronegativity ini adalah tendency to receive electron. The higher tendency to receive electron. Okay, so for example, water molecules H2O can form hydrogen bonds among water molecules H2O. So this is water molecule and this one also water molecule. So in one water molecule there consists of two hydrogen atom and one oxygen atom. So oxygen atom here has high electronegativity. Okay, high electronegativity. So water molecule consists of two hydrogen atom H and one oxygen atom O. Hydrogen and oxygens are bonded by sharing electron with one another. So this type of bond is covalent bond. So this is covalent bond between the H and O in the same water molecule. Itu adalah covalent bond. Okay, tetapi the bond between the hydrogen atom in this water molecule and also the oxygen atom in another water molecule itu adalah hydrogen bond. Okay, hydrogen bond. So hydrogen bonds are attraction forces between hydrogen atom bonded with another atom that is higher electronegativity. Okay, so here between the two water molecule. Okay, this is between the two water molecule, the H and O. The bond between the H and O here is called hydrogen bond. Okay, so role of hydrogen bond in daily life. So this one, figure 5.13, they are protein molecules that form hydrogen bonds among one another in the hair structure of this unduk nga daw. Hair structure. So do you know why hair sticks together when wet? So bila rambut basah kan dia melekat antara satu sama lain. So kenapa itu berlaku? Sebab dalam protein molecules itu ada hydrogen bond. We know that our hair dia consists of protein molecules. So dia ada hydrogen bond among one another. So when hair is wet, the protein molecules no longer form hydrogen bond among themselves. So this one is protein molecules, this one is protein molecules. So between the protein molecules they form hydrogen bond. So when the hair is wet, the protein molecules no longer form hydrogen bond among themselves. Instead, the protein molecules form hydrogen bond with water molecules. So here, this is the protein, this is the water. So they form hydrogen bond. And the water also form another hydrogen bond between another protein molecules. So that's why the hair will stick together. when wet. Okay. Have you ever come across the problem of turning the pages of a book where the pages stick together? To overcome this problem, you lick your finger before turning the pages. So why does a wet finger help to turn the pages of a book? So this is the explanation. So this is paper. So paper contains cellulose. Okay, cellulose in the paper consists of hydrogen atom bonded to oxygen atom O. Okay, so now when you wet your finger with water, okay, wet your finger with water, or you lick your finger, okay, so water molecules on the wet finger will form hydrogen bonds with the cellulose in the paper. So this one, the O and the H, this one H from the cellulose, the O is from the water. Okay, that's why the paper will stick to the finger. So senang lah untuk turning the pages of the book. Okay. Effect of hydrogen bond on the physical properties of substance. So the physical properties of a substance itu are affected by hydrogen bond. So compounds in the form of liquids reach boiling point when the attraction forces between molecules are overcome. In the covalent compound of ethanol C2H5OH, there are hydrogen bonds formed between the molecule, okay, other than weak van der Waals attraction forces. So the strong hydrogen bonds are difficult to break. Difficult to break meaning so more heat energy required to overcome the weak van der Waals attraction forces beside breaking the hydrogen bond. So dia satu heat energy need to overcome the weak van der Waals force, and then heat energy needs to break the hydrogen bonds lagi. So that's why more heat energy is required. So as a result, the boiling points of ethanol is high. Okay. So on the other hand, molecules like chlorine, Cl2, they do not form hydrogen bonds. So they have lower boiling point compared to ethanol. Okay. And then ethanol also soluble in water. The solubility of ethanol in water is due to the formations of hydrogen bonds between the ethanol molecule and water molecule. So this one is ethanol. Ethanol molecule. So between the ethanol molecule is van der Waals attraction forces. Now when we add water here, it will form hydrogen bond. Okay, so the hydrogen atom in the ethanol molecule also form a hydrogen bond with the oxygen atom. This one, oxygen and hydrogen. This one form a hydrogen bond. So this one also hydrogen bond. Okay, that's why the ethanol are soluble in water. Okay, that is hydrogen bond. Okay, we go to 5.5, dative bond. So at the end of this subtopic 5.5, dative bond, you are able to explain the examples of formations of dative bond. So we look at this figure 5.17, formations of dative bond. So here we have hydrogen ion H plus and ammonia NH3. So the H plus said, I do not have electron, but the ammonia said, I have a pair of electron to be shared. So they share the electron. Wow, I have achieved duplet electron arrangement. I am still in octet electron arrangement. So from this figure, we know that dative bond, or also called as coordinate bond, is a type of covalent bond. Dative bond is a type of covalent bond. Okay, sharing of electron, but the electron pair that is shared comes from one atom only. So in this example, the electron comes from the ammonia, share with the hydrogen ion. Okay, so this is special type of covalent bond. So dative bond, electron pair is shared, but from one atom only. Okay, so we look at this example, formations of dative bond in hydroxonium ion H3O+. So the first one here, oxygen atom achieve octet electron arrangement and hydrogen atom achieve stable duplet electron arrangement in water molecule. So this one, water molecule consists of 2H and 1 O. So between this water molecule, dia sudah achieve itu stable duplet electron arrangement and also octet electron arrangement by sharing dia electron. So forming covalent bond, kan? Forming covalent bond. So number 2, the hydrogen ion H+. H+ means dia tidak ada electron in the shell, zero electron. H+ means dia sudah donate dia punya electron. We know that hydrogen H is dia contain one electron only, betul kan? So bila dia sudah donate dia punya electron ini, dia jadi H+ ion. So this one dia contain zero electron in the shell. So what happened? The lone pair of electrons that are not involved in covalent bond in water molecule, this one will be shared with hydrogen ion through the formations of dative bond. Okay, yang dua elektron di sini akan shared with the hydrogen ion. So dia akan form inilah hydroxonium ion H3O+. So di sini kesemua atom H dengan O itu sudah achieve dia punya stable octet and duplet electron arrangement respectively. So itu adalah dative bond. Okay, how about metallic bond? 5.6 metallic bond. You are able to explain the formations of metallic bond and reason out the electrical conductivity of metal. So do you know that exposed electrical wires can cause electric shock? Electrical wires made from metal can conduct electricity. So why metal can conduct electricity? Okay, metal atoms are arranged closely packed and orderly in solid state. Valence electron of metal atoms can be donated easily and delocalized although in solid state. Okay, walaupun dia dalam solid state tetapi dia punya valence electron of this metal atom can be donated easily and delocalized. What is delocalized? Delocalized electron means electron that moves freely and is not owned by any atom nor ion. A sea of electron is formed when the valence shells of metal atoms overlap, resulting in electron delocalization. Okay, so itu adalah maksud delocalized electron. Metal ions that are positively charged are formed when valence electrons are delocalized. And all delocalized valence electron can move freely between the metal structure and form a sea of electron. Electrostatic attraction force between the sea of electron and the positively charged metal ions form the metallic bond. So this is metal atom. So metal atom arranged closely packed in solid state. So dia ada valence electron di sini. This is the valence electron, valence electron, valence electron, valence electron. So what happened is the valence electrons of the metal atom can be donated easily ataupun delocalized. So bila dia delocalized, so dia akan form C of electron. So this is C of electron. Okay, C of electron. So electron itu sudah delocalized. They are forming C of electron. So now what happened? Positively charged metal ions is being formed. Okay, so when electrons of metal atoms are delocalized in the C of electrons, the metal here can conduct electricity. Okay, electron so electron that move freely in the metal structure carry the charges from negative terminal to the positive terminal when electricity is supplied. So that's why the metal can conduct electricity. So this one we have negative terminal, this one we have positive terminal. So the electron move freely in the metal structure, carry the charges from the negative terminal to the positive terminal when the electricity is supplied. Okay, we're going to the last subtopic in chapter 5, properties of ionic compounds and covalent compounds. Okay, properties of ionic and covalent compounds. So different compounds have different properties. So this one is the properties of ionic compound and covalent compound in terms of electrical conductivity. So this one, the first one, this one is solid ionic compound. This is ionic compound but solid. So solid ionic compound, the ion cannot move freely. Okay, because they are tied by strong electrostatic attraction forces. Okay, because this is solid. In solid, the ions, of course ionic compound contain ion, but in solid state, the ions cannot move freely. They are tied by electrostatic attraction forces. So solid ionic compound cannot conduct electricity. Okay, so second one here, we have molten or aqueous solutions of ionic compound. So ionic compound, the keyword here is ionic compound. We know ionic compound contain charges or ion. And another keyword is molten or aqueous solution. Molten or aqueous solution. Molten means liquid lah. Aqueous means aqueous, you add water. Right? So here in this case, ion can move freely, because the electrostatic attraction forces have been overcome. So molten or aqueous solutions of ionic compound can conduct electricity. This one conduct electricity. This one not conduct electricity. And for the third one here, we have solid or molten covalent compound. So solid or molten, but this time covalent compound. So the molecules in covalent compound are neutral. They do not have ions. They do not carry any charges. So the covalent compound do not conduct electricity in all states. Walaupun dia solid kah, dia molten kah, dia tidak akan conduct electricity in all states, because molecules in covalent ini compound are neutral. Dia tidak ion, dia tidak carry any charges. So dia tidak conduct electricity in all states. Okay? And then the second one, solubility in water and solubility in organic solvent. So remember, most ionic compounds soluble in water but are not soluble in organic solvent. On the other hand, most covalent compounds are not soluble in water but are soluble in organic solvent. So dia terbalik. So kena ingat di sini dia terbalik ah. Dia kena terbalik. So bila kamu ingat properties of ionic compound, automatic kamu akan tahu properties of covalent compound. Sebab semuanya adalah terbalik sahaja. Okay, terbalik sahaja. So when dissolved in water, water molecule help to overcome the electrostatic attraction force between ions and break down the lattice structure of the solid compound. So that's why ion can move freely in water. Okay, so what is lattice structure? Lattice structure is the orderly arrangements of atom, ions or molecule of a compound in a solid crystal. Okay, so here, look here. The figure below shows the solubility of sodium chloride in water. So sodium chloride is ionic compound. So of course sodium chloride soluble in water. So water is a polar solvent that has a partial negative charge at the oxygen atom and partial positive charge at the hydrogen atom. So hydrogen atom partial positive charge, oxygen atom dia partial negative charge. Kenapa dia ada partial positive and negative charge? Because in a water molecule we have H2O. Oxygen itu higher electronegativity compared to the hydrogen. So this causes the electron shared in the covalent bond, okay, to be pulled towards the oxygen atom. So the unequal sharing of electron will create the partial negative charge and the partial positive charge, okay, in water molecule. Okay, so here in this beaker we mix solid sodium chloride with water. Okay, with water. So what happened? So solid sodium chloride with water. So what happened? The solid sodium chloride dia akan ionize in water. Okay, ionize mean dia akan jadi ion positif Na dengan Cl, chloride ion. Okay, so the positive ion Na ini ya, yang purple ini will be attracted to the hydrogen atom of the water molecule. Okay, hydrogen atom of the water molecule. Sodium ion Na plus, so dia positif kan, so dia attracted to the negative side of water. Negative side of water adalah apa? Oxygen, oxide lah, oxide. Okay, while the chloride ion here negative, right, attracted to the positive side of the water. So positive side of the water is the hydrogen ion. Okay, so attraction force between atom of water molecule with the ion of ionic compound are strong enough to overcome the electrostatic attraction force between ion themselves. So between ion themselves, the Na and the Cl, dia ada attraction forces between the ion, but the attraction force between the atom of water and the ions of the ionic compound are strong enough to overcome the attraction forces between the ion themselves. So this will enable most solid ionic compound to be soluble in water. Okay, how about organic solvent? Organic solvent cannot overcome the electrostatic force between ions in solid ionic compound. So ionic compound are not soluble in organic solvent. Okay, molecule in covalent compound are neutral and do not carry any charges. So molecule in covalent compound soluble in organic solvent but not soluble in water. Okay, remember that. Okay, how about the melting and boiling point? Melting and boiling point of ionic and covalent. Okay, ionic compound have high melting point and boiling point. So ionic compound are not easily volatile, tidak senang untuk meruap. Okay, for example here we have sodium chloride and NaCl. So sodium chloride and NaCl, sodium Na plus, chloride ion Cl minus, heated. So an ionic compound like sodium chloride consists of positive ion and negative ion attracted to one another by strong electrostatic attraction forces. So high heat energy is required to overcome the strong electrostatic attraction forces so that the ionic compound can melt or boil. So that's why NaCl ini dia punya melting point, boiling point dia adalah tinggi. Okay, ionic compound have high melting point and boiling point. How about covalent compound? Covalent compound with simple molecule, they have low melting point, low boiling point, and are easily volatile. Senang untuk meruap. Okay, for example di sini adalah methane, CH4. CH4. So methane di sini, the van der Waals attraction forces here between the methane molecule. Methane molecule adalah weak van der Waals attraction forces. So only a low heat energy is required to overcome the weak van der Waals forces so that the covalent compound can melt or can boil. So methane, a type of covalent compound, has a low melting point and low boiling point. So here, this is another info. Lizard, nah cicak-cicak di dinding, can stick to the surface of walls due to the reaction between some electron from the molecules of the hundreds of fine hairs found on the sole of the lizard. So di sini ya, we have fine hairs, okay, fine hairs. Dia akan react with the electrons from the molecules of the wall. Sebab itu dia boleh melekat di dinding. So this reaction will form electromagnetic attraction known as van der Waals attraction forces. So this will also help the lizard to stick on the surface of a wall. Okay, next one, structure of covalent compound. So we focus on covalent compound. We have two types of molecular structure for covalent compound. Okay, simple molecular structure and giant molecular structure. So example here, simple molecular structure is water, H2O. Another example, carbon dioxide, CO2. Examples of giant molecular structure is silicon dioxide, SiO2. So this is giant molecular structure, silicon dioxide. Okay, structure. In structure, for simple molecules, small and simple structure can be found in the form of solid, liquid or gases. For giant, very large structure usually exists as solid. In terms of chemical bonds, for simple structure molecule, covalent bonds are strong in the molecule. Okay, in the molecule, and van der Waals attraction forces are between the molecules are weak. Remember, the covalent bonds are within the molecule. Van der Waals force adalah between the molecules. So the covalent bond strong and the van der Waals forces dia adalah weak. For the giant molecular structure, strong covalent bond in the molecule only. Dia ada strong covalent bond in the molecule only, and no van der Waals force attraction between the molecule because of its giant structure. Melting point and boiling point. Melting point for simple molecule is low because only little heat is required to overcome the weak van der Waals attraction forces between the molecules. But this one, for the giant molecule, the melting point and boiling point is high because a lot of heat is required to break the strong covalent bond. Okay? Uses of ionic compound and covalent compound in our daily life. Okay, this is examples of uses. In industrial sector, the ionic compound of lithium iodide, LiI, is used in batteries. Paint, ni batteries paint contains covalent compounds such as pigment and turpentine solvent. In agricultural sector, the ionic compound of ammonium nitrate ionic compound and also potassium chloride used in fertilizer, baja. Kemudian pesticide used to kill weeds, okay, rumpai and insect contain covalent compounds such as bromoethane and chloropicrin. Di sini, okay? And then medical sector, the ionic compound of sodium bicarbonate used in antacid to relieve gastric pain. And paracetamol is a covalent compound used to treat fever and also irritation. In domestic use, detergent contain ionic compound such as sodium chlorate 5 that is used for domestic cleaning, and glycerol is a covalent compound added to skincare, okay, skincare product to moisture skin and help to prevent dry skin. So these are the some examples of uses of ionic compound and covalent compound in our daily life. So that's all for chapter 5, chemical bond. Chemical bond, involves valence electron. Okay, we have between metal and non-metal transfer of electron. Okay, metal will donate the electron forming cation, and non-metal accept the electron forming anion. So the cation and anion, they akan attracted to each other, electrostatic attraction force to form ionic bond. So ionic bond form ionic compound. Okay, and then metal element, when the electrons are delocalized, forming sea of electron and positive ion, between these two there are electrostatic attraction force forming the metallic bond. And then we have dative bond. Okay, dative bond is a type of covalent bond where the electrons are donated or not donated, shared by one atom only. Okay, so sharing of electron between non-metal and non-metal forming covalent bond. Okay, so 3 types of covalent bond: single bond, double bond, and triple bond. Okay, so itu adalah covalent compound, forming covalent compound. And then the covalent compound, we have giant molecule structure and simple molecular structure. And then we have hydrogen bond also. Okay, hydrogen bond also. So this is the summary for chapter 5, chemical bond. Thank you.